Thank you for joining me for the very first live episode of Real Talk, a roundtable discussion show where I bring on guests to talk about hot button issues in society. Now, you'll notice that there's only 2 guests today, and that is intentional. So if you were here for the last episode, you know just how much information there was to discuss regarding climate change and the Willow Project. There were so many opinions and sides to discuss, so today I have brought back on Dr. Nick Soltis, geologist and earth sciences professor, and McCaitlin Lawson, president of the Sustainability Club here at UINDY, to have some more in-depth discussions about climate change. Thank you so much for both being here today. I really appreciate it. In the last episode, there was so much ground to cover regarding the climate crisis. Even I didn't realize how much controversy and questions surrounded this topic and just how much went into it. Now, last time we heavily discussed the Willow Project specifically, but today I want to focus more widely on climate change in general. So, Dr. Soltis, I'll start with you. What is the very basic scientific discussion or definition of climate change?
So climate change is just the fact that the Earth's climate will change over time. And that is not something that is controversial. We know the Earth's climate has changed, and it is changing. It's a dynamic system, right? So there are times in Earth's history when the climate has been much hotter than it is today, and there's been plenty of times when it's been much cooler today. With current climate change, though, we notice something that really is quite different than what we've seen in the past, and that is that the rate of change is much higher than what it's been before. And we can try to figure out what the causes are. There's lots of different factors that have caused climate to change in the past, from volcanic eruptions, solar activity, even the position of the continents can have an influence on what the climate is. And then, of course, there are greenhouse gas concentrations, right? So things like carbon dioxide, methane, water vapor, nitrous oxide, that are all gases that can trap the Earth's outgoing radiation and re-emit it in the form of heat. So all these different variables come into play, but when we look at modern climate change, it's quite different, right? We can look at every culprit, solar activity, volcanic eruptions. They can't explain the rate we see today. And the smoking gun is that it is greenhouse gases with carbon dioxide, right, being the major culprit. So yeah, that's basically what climate change is. The fact that climate changes, but modern climate change is really what is kind of the controversy right now. From a scientific perspective, it's not super controversial, but when we talk about politics, economics, how do we deal with it, that's when the real discussions begin.
Absolutely, and that's what I was referring to, exactly that, the controversial side being the, financial side of things. How does legislation affect all this? So I think I can speak for a lot of people when I say I've been hearing, the sky is falling for several years. When did climate change become a talked about issue?
So we've known about climate change for a while, and it's interesting how much some companies like oil companies that come out, they knew about climate change in the 80s and were talking about it, right? But really, I would say in the early 2000s, a lot of the conversation in the general public was, is climate change happening? I would say recently, maybe in the past 5 years, maybe 5 to 3 even, we've had this idea of climate alarmism, where we've gone from the debate to, is it happening, that it's happening, the sky is falling, do we even do anything about it? So the conversation has shifted very, very rapidly. The needle has shifted very rapidly, which leads to a lot of confusion for people, obviously, when it shifts that fast. And it does make a lot of people feel uncomfortable. We see things like climate-related anxiety. So there's psychological ramifications to this as well.
Absolutely. And McCaitlin, I'm curious, do you recall a time when, you really started to pay attention to the climate crisis and hear about these things?
I don't think necessarily from a young age. Like I was telling some of you earlier, I grew up on the West Coast, so even growing up, I didn't even witness snow before the age of 7. And when I did, there was only an inch of snow and school was called off. Snow was so foreign in Oregon at the time. But here in Indiana, the seasons across the board, the climate and weather we experience is so drastic, and I had never like experienced storms before, so I feel like that was kind of a wake-up call, you know, just experiencing all of those 4 seasons, which I didn't really know in my past. But I personally started getting interested in the environmental sciences and paying attention to climate a bit more my senior year of high school when I took a chemistry class. My chemistry teacher did a really good job of explaining climate issues to us and just really honing in on the importance and why it should matter to everybody.
So as we kind of discussed a little bit before, you know, there are all kinds of different sides to, you know, that you need to take into account when it comes to this. It's not just some easy conversation of whether it exists or not, you know. So there's financials and business plans. So how does it seem that there's always, like I said, there's more than one side, and they're, you know, the environment and the business plan and financials, they're never on the same side. So where does the controversy actually lie in this, and what can we, you know, maybe do to help it kind of move all together?
Yeah, so I think a lot of the controversy comes from, which is what a lot of political issues boil down to, is how much regulation should there be, and do we use the stick? Do we punish people who don't do what they're supposed to, or do we use the carrot? Do we reward people who do what they are supposed to, right? So for those who favor, you know, personal responsibility, a lack of government interference, you know, the issue becomes an issue of, you know, economically, does it make sense to support these climate change initiatives? You know, one of the things that always comes up with like fuel efficiency, right? That's an easy way to combat the use of fossil fuels, is to increase the fuel efficiency of vehicles. But we see that becomes a controversial issue because some people say, you know, we need to encourage businesses who, you know, meet these standards. We need to punish businesses who don't meet these standards, or we need to let these businesses make their own decisions and do what is right for them. Right, so we get to this philosophical thing that really divides a lot of political issues. And how do you approach it? Do you regulate it? Do you not? Do you reward? Do you punish? Do you just assume everyone will do what they're supposed to? Right, and there's no clean right answer to any of that. You can't really, I mean, based on your values, you can advocate for what you feel, but there's nothing that is objectively right there.
Absolutely, and I think that's why it's so tough, and there's these continuing conversations of, oh, we need to do this, but it's hard to get much done because what can you do when not everyone agrees, right? Yeah. So it seems like weather events are getting more frequent and more intense around the world. What's causing this, and what can we do about it?
So that's a great question. One of the ways, you know, you mentioned people have their lived experiences, and you remember environmental issues you faced or surprised you when you came here. Mm-hmm. And a lot of people who have been around for a while, that, you know, they recall, like, I don't remember seeing this many severe weather events, right? I don't remember it flooding this much. And what happens here, particularly with rain events, is with climate change, basically the amount of water the atmosphere can hold is directly related to temperature, and it's actually an exponential relationship. So a warm atmosphere can hold way more water than a cool atmosphere, right? So that's why in the winter a lot of people get like dry skin and nosebleeds, because the atmosphere just cannot hold very much water. The air feels very, very dry, right? So with climate change, even small changes in climate or temperature result in the atmosphere holding more water. So the atmosphere holds more water, that also means it can dump more water, right? So if you have a storm or a hurricane system coming through, there can be a lot more water, right? So more flooding, more of that. And we see a pretty close relationship with thunderstorms and hurricanes, particularly with the amount of water they're dropping. The relationship between, say, tornadoes and climate change is a little bit more unclear. The data's still a little bit fuzzy, trying to figure that out. And conversely, areas that are drier tend to get drier with climate change. A classic paradigm is wet gets wetter with climate change, dry gets drier, right? So there's a finite amount of water on Earth, so if areas are getting wetter, conversely, other places are getting drier. So on the flip side, we see a lot more drought events in areas that are traditionally dry. Droughts, windstorms, dust storms, all those kinds of things. We also see changes with how the jet stream behaves. So the jet stream usually has what we call a nice geostrophic flow, where it's going west to east in the mid-latitudes, but it does make waves occasionally. That'll bring cold weather down, warm weather up occasionally. Well, with climate change, when we have these differences in temperature between the poles and the tropics changing, these waves can get bigger, leading to both increased heat events and increased cold snaps as well. So a lot of people say, well, it's so cold, like that can't be climate change, we can't have global warming. And that's fundamentally not what climate change is about. It's not just about things getting warmer, but those changes in climate changing profoundly how the atmosphere can function.
Mm-hmm. I'm curious because it seems like the two sides are usually people that think these are human influences and, oh, we need to do what we can on our side to stop or prevent these things or whatever, versus the other people who say, oh, these are just the natural cycles of the earth. Mm-hmm. So how much of this is due to human influence versus the natural cycles of the earth?
Go ahead.
You want me to start? Okay.
Yeah.
So that's a great question. So we talked about there are natural things that cause climate to change. It's been way hotter, it's been way colder, right? But with modern climate change, there's a few smoking guns. So we are able to measure the amount of carbon dioxide in the atmosphere, and we have records that are concrete records directly connected going back, into one of the most famous data sets goes into the 70s. And you can see the curve straight up. And there's a very, very tight correlation with the amount of carbon dioxide in the atmosphere with temperatures, right? So we know that relationship. Well, some people say, well, volcanoes, they produce carbon dioxide, right? Cow farts produce carbon dioxide, right? We've all heard it. But fossil fuels also produce carbon dioxide, right? Fossil fuels like oil, coal, gas, they're all carbon. So when you burn carbon, they're organic carbon. They have things like hydrogens attached. When you burn them to release that energy, that carbon has to go somewhere. You can't create or destroy matter, so it becomes carbon dioxide gas. So we understand that, we get it. That's where the carbon goes. But how do we know that comes from fossil fuels and not volcanoes? Well, so that's why I'm going to drop some science on you. So we have these things called isotopes. These are elements on the periodic table. So like helium is an element that always has 2 protons. So it's always 2 protons. But the number of neutrons can change, right? And the number of neutrons will give it different masses. So you can have different atoms of carbon with different masses based on how many neutrons they have. You might say, why is that important? Well, living things, we're all lazy, right? So things like plants and animals, plants especially when they photosynthesize, when they take in carbon, they preferentially take in light isotopes of carbon because they're lazy. It's easier to work with. So when those plants get buried and they, over millions of years, become coal, that coal is made up of lighter isotopes. So when you burn it, you release lighter isotopes. So every single substance has an isotopic signature or fingerprint. When we look at modern atmospheric carbon and look at the isotopes showing up, they are the proportion that comes from the burning of plant material in the form of fossil fuels. If they were volcanic, they'd be way heavier in the heavier isotope, and it's not. So we have a clear fingerprint, a clear smoking gun. We know where that carbon dioxide is coming from, and we know that it is leading to these increases in global temperatures.
Well, that definitely provided a lot of context and definitely answered the question I have, so I thank you for that. I think a lot of, one of the controversial, I guess, or maybe it's a lack of understanding, and maybe that people can benefit from hearing what you had to say just now. I think that adds a lot of context to these things. But I think fear could also be one of the reasons that people are so hesitant to believe that this is happening and, push for change. So, I kind of think of it as it's when little kids, they cover their eyes and think that no one around them can see it, that it'll just go away, right? But that's not the case, and that's not how it works. This kind of thing is scary and it's very real. How do we get people to wake up and take action? I know, McCaitlin, you were saying how, your high school teachers kind of brought some things to light for you and made some things more clear. So in your opinion, what are some things, what can we do to have people wake up and understand what's happening?
I think it works on a very individual, personal level. I think a lot of things that Dr. Soltis was mentioning, just really understanding the science that goes into it, I think that was really helpful for me to have those images and be able to associate those to real scientific things, have those exact explanations that I didn't really have before. So that's what was really helpful to me. I think it also just becomes more of an issue to people when it's actually there's the phrase happening in their backyard. When those issues are like actually happening to them. So it could really, I think, go either one of those ways usually.
Yeah. Dr. Soltis, I'm curious what your kind of side of that is as well.
Yeah, so it is interesting because, you know, they've done studies, right? It's important to science to figure out how do we communicate with people to understand climate change. Like climate communication is a huge field. And one thing we know is that, you know, you can bombard people with facts and like teach them and teach them and teach them, but that fundamentally does not change longstanding beliefs people have, right? And I think part of that comes from some people, you know, it's a really overwhelming feeling, a really overwhelming part of the human experience to realize that as a species we can impact our planet like that, right? We kind of think if the planet does its thing, we just live on it, but to know that we are doing something can be quite unsettling for people and does not fit in with their schema for how things work, right? So there can be a dissonance there where people don't understand that. But I think there's also a lot of people who, you know, they understand, they know, you know, they have a sense the climate's changing. You know, they, like McKenna said, they have experience of their own life. Like, wow, I remember there used to be a lot more snow in Indiana in the winter. I just don't see that like I used to. Or there's a really scary weather event that really is making me rethink how I think that. But then, like you said, the question is, what do we do, right? You feel so small, like an individual, like, what's my role? And there's a lot of discussion, you know, a lot of people look at people like celebrities or millionaires, like, well, they're flying their private jet and like releasing all this carbon, like me riding my bike, what is that really gonna do, right? So I think there's a feeling of just like helplessness sometimes that can lead to some of that climate anxiety I've talked about before, or just feeling really unsettled. But I mentioned this last time, part of the biggest thing is, you know, it's great to recycle, to do all those things, every little bit helps. But it's also really important to have maybe these tough conversations sometimes because it is a bigger issue that's going to take politics to solve. You know, it can be a barrier, but it can also be the solution. And I think we are seeing, you know, a lot more Republicans who people think of as being traditionally, you know, pro, let people do their things, it'll take care of itself, but starting to be more concerned about climate change and starting to be really more willing to talk about it whenever they're seeing the impacts on, be it fisheries on the coast or on crop production. I think people are becoming more open to conversation, but it takes us, the everyman or every woman, every person, to kind of, you know, push candidates, to research candidates, and to make climate change and these environmental issues more important political issues. And not just kind of the fringe thing like, oh, if this works out, it works out.
Yeah, absolutely. And you bring up a great point about, you know, longstanding beliefs are sometimes hard to change for people. And I think that says a lot about, I think, our generation as well. I think a lot of this might have to do with age. You know, if you believe a certain thing for a long time, then you aren't necessarily going to want to see things change or care to see things change. You know, it has more effect probably going to be with our generation, our children, our grandchildren's generation. So how do we change the narrative that it's everyone right now, ours, and just everyone's responsibility to make that a change?
You mean the responsibility on the people rather than the government?
Yeah, like I think that there's obviously a lot of people, whether it's different groups of people or organizations trying to bring awareness to the government. But, you know, I think a lot of the older generation is probably not as concerned. So how do we get everyone to kind of rally together, so to speak?
I mean, I think human connection is always so important, and a lot of times, and I'm guilty of this, is sometimes you avoid tough conversations, tough political conversations, and you're just like, I don't want to deal with it, like it's going to be too much. But there's ways to, you know, take things that are unfortunately become politicized and talk about them in a less political way. You know, talking about things like choices you can make in your own life that would reduce your carbon footprint, right? Sometimes just making people aware of like, oh wow, like when I do this, when I leave the lights on in the room, that produces, you know, a lot of carbon, and I could not do that. Even better when you can tie that to something that might be more of an initial reward or a right-away reward, and saying like, hey, you save a lot of money when you don't leave the lights on. Your electricity bill goes down, right? So there are ways to kind of frame things in this kind of economic way that people typically respond to because we all like to save money, not spend money, right? And a lot of, we kind of talked about this a little last time, a lot of things like shift to renewables, there is value in that, not just for protecting our climate, but also for creating jobs and creating new opportunities for people. So it is kind of about shifting those conversations that way. It's not so much as arguing you rarely ever have an argument where someone comes over to your side, right? It's more about this kind of cost-benefit analysis. And, you know, like McCaitlin said earlier, just educating yourself. One of my favorite quotes is a quote that Barack Obama said once that was, "It's not cool to not know what you're talking about." And I think, unfortunately, today, a lot of people are really cool with not knowing what they talk about, right? Mm-hmm. So I think educating yourself and coming from a place of knowledge and also a place of positivity, looking at what we can do instead of looking at the negative and kind of getting out of that kind of getting stuck kind of mindset.
Yeah, I think that's great. And now that we kind of, you know, have some understanding of how do we get people to care, and hopefully they do, I want to talk about solutions. So I know a little bit last time we did talk about like, for example, battery cars, like things like that. So how much potential does battery-powered vehicles have to help in like solar power or wind energy, things like that? Like how much are these solutions, potential solutions, going to help?
I mean, potential is always there. It depends what we invest in it. It's not there yet, right? And we're never going to make a clean break from fossil fuels with where we are now. A more sustainable energy future is going to require the reduction of fossil fuels while ramping up the renewables, right? And if you don't do it at the right rate, it just doesn't work, right? Because if you're driving an electric vehicle and your source of electricity is a coal plant, right, we're still kind of feeding into that same system, right? So there's a lot of smart, interesting technologies that can kind of blend the two, and it is a really exciting time to be in those fields. But again, it's important to realize we can't just flip a switch. We can't just say no more oil, no more gas, no more coal, right? There's always going to be compromise. There's always going to be tension. And until we can get renewables where they need to be, there's going to need to be a balance between those things.
Absolutely. Is there a difference, and maybe could you explain the difference and the pros and the cons between some of those energy sources that I brought up?
Yeah, so a lot of these energy sources are going to be specific to where you are. So if you live in like Seattle, Washington, solar might not be the choice for you. But Washington and Oregon, actually, their energy infrastructure is about 95% renewables with an asterisk, because their renewable is hydroelectric power, right? So hydroelectric power from rivers, build dams, is renewable. It also severely alters rivers and does some crazy things with the ecosystem. So a lot of environmentalists have been a little bit critical about claiming that they're truly renewable when there are some of these issues. But Indiana, for example, has great wind potential, right? If you've been outside last weekend, you know we have great wind potential. Places like Hawaii have geothermal potential, right? So there's not always a one-size-fits-all, at least we're not there yet. Like the ultimate goal in energy production is what we call hydrogen fusion, which is what stars do, where you take hydrogen, the most abundant gas in the universe, fuse it together and release a huge amount of energy. Right now you can do that only in the cores of stars. They're not really suited for Earth, but that's always been like the future golden beacon, as it produces virtually no waste. Hydrogen is everywhere, it's in water, right? It's everywhere. And like, if you ever played like SimCity as a kid, that was like the final power plant you could unlock, was the hydrogen fusion plant that had like no drawbacks whatsoever. It's not quite that perfect in real life, but that's like what people aspire to. But again, it's kind of mixing and matching and finding what works, right, for where geographically you are.
That's fascinating, and I think that that's like really interesting. Obviously, things are going to change depending on location, but it's awesome that we have so many of those different kinds of resources. Hopefully that takes hold and is sustainable. This past year, scientists successfully created more energy than they put into a nuclear fusion reaction. Is this potentially the clean power solution of the future?
Yeah, that's the dream. Fusion, like I said, that's what stars do, so it's very, very energy productive. Hydrogen's very, very abundant. Now the caveat there is they did produce more, but it's not going to power anything, right? So there's still a long way to go But it was super exciting to make that step, as every single little step counts. And I just want to clarify, as a lot of people aren't sure, there's nuclear fusion and nuclear fission. So nuclear fission is what nuclear power plants do now. And that's where you take a really, really massive, unstable atom, usually uranium, and you split it to release energy. So that's non-renewables. You do have to mine the uranium, which isn't hyper-abundant. And then you get, as an end product, waste that is radioactive that you have to store, right? It is, however, relatively clean, as the only thing that's produced in that reaction is water vapor from the coolants used to cool down the reaction. But fusion is all about taking a very small atom, like hydrogen, and fusing it together to make helium to release massive amounts of energy.
We're going to switch gears just a little bit. Artificial intelligence, also known as AI, is gaining traction and is continually becoming more and more popular. Are there any AI initiatives that you've heard of that are pushing development of clean energy products, or even just finding solutions to eliminating toxic conditions in oceans or landfills, for example?
You heard anything?
I'm not quite as familiar with AI and how it would be used in an environmental setting.
Yeah, so AI it's fascinating, because I mean, for me personally, that's probably the fastest I've ever seen technology move in my life, right? And I'm a kid from like the internet generation, like I went from no internet to internet, but like AI is just, it's kind of boggling. There's lots of dimensions. You have like your chat bots and stuff that can like answer any question you want to varying degrees of success. But there's also like AI in the form of things like machine learning, which is basically where you train a computer to perform very, very complicated tasks that use a large amount of data, which can be helpful for a lot of environmental applications. There's also talk of, self-manned like automated vehicles that you could use for like oil spills and stuff. And I mean, drones aren't artificial intelligence yet, but drones have a bunch of environmental applications, not just for taking pictures. They can sense things, they can measure things, they have different sensors. So the technology is really exciting, and I'm sure with AI, and particularly from my perspective, geoscience, with machine learning, that's opening up a lot of possibilities, but there's also a lot of challenges with it because the Earth is such a complex system. Sometimes computers and AI have a tough time making sense of those systems. To give you an example with weather forecasting, there's a lot of talk using machine learning and AI to do weather forecasts, and they just can't. They're really bad at it. Without that human oversight to see what's happening, because the atmosphere is such a chaotic system, machines just can't really make much sense of it.
That's fascinating, because I think that people now are just assuming that AI is like all-knowing and great, but I think having that human interaction with it is really fascinating, that we need that. Okay, let's talk about, just to wrap it up, if we're going to save the world, I want to talk about, of course, like, where do we start? We talked last time about grassroots change and how things start on a small level, and I know you said everything helps, So as a geologist, you're well versed in what resources we have in the United States and what resources we import. So what could we be doing more of here to increase our energy independence, and what practices do we need to expand on and phase out, per se?
Yeah, so we've talked about, obviously, the goal is we want to become less dependent on fossil fuels, right? And there is economic benefit to that. It frees up us up a little bit, though there will be, obviously, some costs. We do make money on that. So. But one of the things we need to look at is the renewables. How do we increase those? How do we get those online? And how do we make them more efficient? The second piece that we haven't talked about much, and that is technologies that can remove carbon from the atmosphere. And that's a technique called carbon sequestration, where you take atmospheric carbon and you put it somewhere where hopefully it's going to stay, right? So a popular thing is, for all the tree planters out there, right? Trees photosynthesize, they take in carbon dioxide. So that's great. Plant trees, that helps. The issue is, and why that's not the solution, is because of the time scale. Trees will cycle carbon very quickly, carbon in, carbon out. Where fossil fuels represent a very, very slow part of the carbon cycle, where it takes those things millions of years to form, yet once we get those and we burn them, we release that carbon almost instantly, effectively shortcutting the carbon cycle. So with carbon sequestration, we need to look more at long-term solutions. That is actually taking carbon and putting it back into the earth.
Yeah.
Which there has been success with that, but we probably need to do it more.
Right. And I know that we could talk for hours, as we all know, but of course we're out of time again. So just to wrap up here, thank you so much, Dr. Soltis, for coming on, and Caitlin Lawson. Appreciate you all for joining me once again for another episode of Real Talk.